Bismillahirrahmanirrahim. My name is Muhammad Shweb, and today in this tutorial video we'll learn how we can configure S7 300 and S7 400 PLC controller to communicate with WinCC SCADA over MPI communication interface. So in this video tutorial we have the two steps. In the first step, we'll configure the semantic manager, and in the second step, we'll configure the WinCC SCADA to communicate with the S7 300 or 400 controller. So let's see practically. So we will open the semantic manager. Double click, open the semantic manager. So once semantic manager will open, this step 7 wizard will automatically open. Just click at next and select the any of the controller who can support MPI communication interface. So I will select CPU 314, then click at next. I will select the lateral language and then click at next. Put your project name. So I will put MPI communication project 1 and click at finish. Then select the semantic 300 station and then double click at hardware. So we will add here in the first step the interface module. Select the any interface module, and then we add some digital input module and digital output module. Suppose select any of the digital input module, just select, drag and drop here, and any of the digital output module, just select, drag and drop here, and then click here, save and compile. Once the compile successfully, so we'll just see our starting address of the digital input signal and our output signals. So right click, add symbol. So here you can see our starting address I0.0 and our commands output starting address. Click here the added symbol Q4.0. That's it. Just click at close. So now we'll add a data block. We'll create all of the variables inside that data block. Right click here anywhere and insert new object, then click at the data block. I'll not put it in symbolic name. I'll just put it simple db1. Click OK, and then open the data block 1. Once the data block is open, we'll create our tags. I'll put the pump 1, feedback, boolean, false, and similar manner pump 2, feedback, boolean, false. And our next step is pump 1 command, that is our binary output signal, and then we'll put pump 2 command boolean, and we configure digital input signal and digital output signal. Now we'll add some analog signal. I'll add level. I'll put the int 0. Then I'll put the temperature and then 0, then speed 0, and in the for the analog output, I will put the one tag level SP set point. That's it. Then click at Save button, and after that click at Close. Now open the OB1. Once the OB1 is open, I will develop some logic here. Suppose I'll add it. So I want once my input signal I 0.0 is gain, and then I want to do my common feedback signal, and this is for my pump 1. I will insert a new network for pump 2. So once I 0.1 is gain, then I want pump 2 feedback should be true. And here I just want to add some more signals. Once my command signal also become true, this command signal should runs true, then this should also true. And I also want parallelly, like my output Q 4.0 should also be true. So similar manner, I will add it here also. Command, and also the output Q 4.1. That's it. Now I will insert one more. We'll put some logic. Suppose I want once the output Q 4.0 is true, in that case, some static value should move in our analog tag. So what? So 24 and db1 dot my first tag is level. So as you can see, dbw2 address is assigned for level. So just move like 25 value, and db1 dot temperature, and again I will just drag and drop the move block 26 value in the db1 dot speed. Okay, fine. So I will just copy and paste it here, and I just want to copy paste. So once my Q 4.0 is true, then the static value will move, and once it's not true, in that case I want my level set point value should be moved here. Level underscore S3. I will just copy and paste. Okay, that's it. Click at Save button. So now our logic is completed. So now we'll download this program inside the controller. So if you have the physical controller, you can directly click here in the download button. But for my case, I'm using the PLC sim simulator. So click it here. Hmm. Select here the PLC SIM MPI and then just select it and click a download button. Click yes. Okay. Okay. Yes. So you can see our program is successfully downloaded in the PLC SIM and is showing the run status. Now we'll check our logic is working perfectly or not. Click here insert input module. Then we need output module and our output module is starting at as 4. I will change 0 to 4. So if I turn on it, you can see our output also on for the second also. So our logic is working perfectly. So we'll finish our first step, the semantic manager configuration. Now we'll move toward the second step, WinCC SCADA configuration. So for that, just click here, the semantic manager WinCC Explorer. We'll click it here. So once the WinCC Explorer open, click here file, select new, and then select the single user project. Click OK. Put your project name, suppose MPI Communication Project 01. Click at the create button. So once our project is open, so first step we'll configure our tag in the tag management. Right click, open. Then right click over the tag management and select add a new driver and select the Semantic S7 protocol. Okay, then select the MPI, right click, system parameter and select the unit. So if you are directly communicating with the physical hardware, in that case you have to select the MPI. But in my case, I'm using a PLC SIM, so I will select the PLC SIM MPI. So click at OK. Okay, then right click, create a new connection. So put the connection name. Suppose I will put the name of connection, plant connection, and then right click here, click at the connection parameter. So here station address, you have to make sure this this configuration is matched with your PLC semantic manager program. So for that, come here, open the hardware configuration. Okay. Come here in the CPU, right click, object property. So here you can see address is 2. So this address is correct. Then the rack number. So here you can see upper side, the rack is 0. So that rack number also correct. Then the slot number, where is our CPU is located. So our CPU is in the slot 2. So we'll update the here the put the slot 2. That's it. And then just click OK. And then output. Suppose in this tutorial, we are going to simulate some mixer area in the plant. So I can put just simply mixer. And then I will add here my tags. Suppose I must first tag is on one feedback. And here I will select the binary tag. I will select the address. So for that, I will open my program OB1. So our program is open. So you can see the POM1 first address is DB1 and BX 0.0. So our case also. So address should be 0.0. Press OK. And then just duplicate the same tag details. I'll just update it from 2, and here address is already correct, 0.1. So it's same as here. So I'll add one more tag here. Suppose just pump2 binary tag. So I want just output Q 4.1 value 4.1. So this here Q 4.1. So here you can add any of the tag like bit memory tag, input I0.0. You can configure it here. So our next tag is from one command signal that is also binary tag, and here our address is this one, db1 bx 0.2. So 0.2, click OK. So we have to select db 0.2. Let me recheck. Okay. db1 dbx 0.2. So I will put db1, click OK, and I will just duplicate. So our next command address is db1 dbx 0.3. So it's already the same. Okay. Now we'll configure the analog tags like level, and it's like sign 16-bit value. So you can see it here. Here is the level address db1 db2 dbw2. W stand for word. So I will come it here. So and I will put it 2 db1 word. So you can see our tag is same as it's here. So you have to make sure your address should be the same. So I will just change the name, temperature, and I will here my part temperature address is 4, and then speed, and speed we have address 6, and then level set point you have address of 8. So we recheck our all addresses. Suppose 2, 4, 6, and for the set point I have db1 dbw8 for the set point. So that's it. We'll close the tag management. Now we'll configure our graphics screens, SCADA graphics screen. So before that, we'll do some initial configuration. Here, right click over the project name and then property. Come in the user interface. As in the previous tutorial, we'll see in this whole tutorial series, we'll use the WinCC 3D global design. Select OK, then press OK. And after that, come here in the computer, right click, startup, make sure graphic runtime is selected, then come here in the graphic runtime, select the title, minimum, maximum, and status. Buttons. Okay. Click OK. Now right click, open the graphic designer. In the previous tutorial video, we learned how we can develop static graphics So same graphic we'll use inside this tutorial. We'll import those all graphics in this tutorial, and we see uh, how to import other project graphic in your project. So just click at open, just copy the project name and then close it. So we'll open the same project, this project, the project folder, and here we have the like symbol and other graphic from I just copied from the other project, the previous project, and then just paste it here. That's it. So now we'll open our graphic screen. Click here and select the open. So now here our graphic screen is open. So our first step, we'll select the background and then come here geometry. Just change the resolution as your monitor resolution is there. I'll put 1920 and then put 1000 and I'll zoom out. So as you can see, our SCADA graphic screen is ready. So this is the same graphic screen that we already developed it. So now we just link our tags, pose level, right click, and then here the configuration dialog, select the tag level, here MPI mixer, select the level tag, and then click OK. Similar manner the temperature. And then pressure. So select the speed, press OK, and then level set point. Let's select here level set point. Okay. Now I want once the input I0.0 is on. So once the feedback from the field is received, my pump color should change. So then I have to add the animation, select the pump, click animation, then double click add a new animation, and then select the tag and pump 1 feedback and select data type Boolean. Click add property, select the basic color. So I just want once the value is true, in that time my color should change. So I just select this color. And similar manner the pump 2 also. Click here animation, add a new animation, select pump 2 to tag, and then data type should be Boolean. Add a property, basic color, and then color should be green once the pump is running. That's it. Then I want once the level value is changed accordingly by this level also inside the tank also change. Come here the simple property, the fill level value, right click, tag, and select the level. So that's it. Just click save and then right click here over the tab and define picture as a startup picture. Save and just run the click at run. So here it is. So here you can see we are getting some values. So everything is healthy. So I will just open the simulator. I will turn on I 0.0. So as you can see, we are getting perfectly our input status here in the WinCC SCADA runtime. Suppose if I want to run it second pump also. So here you can see we are getting successfully those value also. And here the upside you can also see we are getting the value. So if I turn off it, in that case, we in the set point we don't have a value. So we put it like 74, some value. So as you can see, we are getting the value here also perfectly, and here the tank level also is coming perfectly. And if I will change some value here, so as you can see, our some static value is moving these analog tags. And now we'll test the command signal also. I will stop this. So we'll open, and I will just create some small button here. I'll put font, and the font size I want to increase. Select the button, and here put some font size, bigger font size. Okay, perfect. And then now I want, once I click the button, then the true value should go in PLC. So here, click at event, then mouse, press left, right click, direct connection, select the constant 0, and then select the tag. So my one command, click OK. That's it. I will just duplicate this tag. So we'll just change the text from on to off. And come here the event, select, and direct connection. And here actually it should be 0, and here it should be actually 1. Here we put it 1. Once it's on, then 1 should move, and once off, 0 should move. That's it. Just save it and run. So now I just want, once I press this button, then this pump should run as in the logic we already put it. Once the input came from the SCADA, then this run feedback should come. So once I will press on button, you can see my pump is running. And once I press the off button, then my pump will become stop, and accordingly the upper side analog all value is changed. That's it. How we can configure S7 300 or S7 400 controller in WinCC SCADA through MPI communication interface. Thanks for watching this video.